Hey everyone, and welcome back to another talk here at the TestCon Europe. This time we have Lee here with his talk Continuous Performance Testing in DevOps. And Lee has more than 25 years of experience in software quality and testing and is the founder and CTO of Utopia Solutions. So, hey Lee, how are you today?
Doing well. How are you?
Good, thanks. So, your talk is about the relevance of performance testing in DevOps. To be honest, accessibility testing wasn't the first thing I thought about with organizations which moved to DevOps. So I'm quite interested in it. So without further ado, let's jump right into it and have fun, everyone.
Thank you. Thank you so much. And thank you everyone for, excuse me, for joining my session today, where I am going to be talking about continuous performance testing in DevOps. I'll give you a quick introduction before I get started. Again, as we just heard, I'm CTO of Utopia Solutions. I focused the past 25 years or so on test automation and performance testing. And more recently, I've been focused on helping organizations bring those activities into Agile and DevOps cycles. So I want to start out with maybe a controversial statement. Certainly for those that fancy ourselves as performance test engineers, and that is performance testing is dead. And hopefully now I've got everyone's attention. So let me qualify that statement and say that traditional performance testing is dead, at least in DevOps environments. And to understand why I might make such a potentially controversial statement, let's take a look at what traditional performance testing generally looks like. That was born out of the waterfall model, where a single cycle stretched out over many months. And then after functional testing was completed, we developed and executed large-scale system-level performance tests that typically lasted many weeks. And I spent a good part of my career helping organizations set up centers of excellence that became very effective at executing this type of performance test and enforcing the often strict rules that went along with that. Rules like your app must be functionally complete, because if you can't prove that it works at least in a single user mode, how can I test it under a multi-user load? And for the entire time that I'm doing my work from script development through execution, you better not change that code, because I might have to start over. Oh, and of course, if you want those results to mean anything, you better be in a production-like environment. So let's say we do that. Let's say we execute
One quick interruption. Are you sharing slides right now? Because we cannot see them, actually. Maybe there's some
I thought I was.
there.
Sorry about that.
Sorry for the interruption.
No, all good.
All right, we are good to go.
Okay. Sorry about that. So let's say that we do execute that traditional style performance test at the end of a long release. Or what if we even do that as part of shorter release cycles, if that's something that we can possibly do? What if we find issues? Our options really aren't very good, right? We either delay the release, right? And which means we're delaying that value that we're delivering to our customers, or we do release and potentially get hit by the freight train. And the freight train has lost revenue, it's lost brand value, lost customer loyalty. It's also the increased cost of remediation compared to if those issues were found and addressed early on. But either way, our options are not good. So what if I try to do something a little bit different and perform that traditional performance testing at the end of each of my development sprints? And I think that seems like a logical approach. The thought being that if I start relatively small and I build my performance tests as I go, that I can somehow keep up. But the reality is that there's really no way that we can follow the rules of traditional performance testing if we're taking an agile approach to development. If we're waiting until new features are functionally complete and tested, there's really no time to enhance and maintain that performance test. And we're not going to freeze our code for a sprint or worse, multiple sprints while those performance testing activities are taking place. And we end up trying to combine these short, agile development sprints with lengthy, rigid performance tests. And again, we end up with a disaster. So what it appears that we're searching for here is more of a continuous feedback on performance, or what I call continuous performance testing. So that is, and maybe it's better to talk about what it isn't, because I think there's a lot of common misconceptions about that. Certainly when I first tried to think about this and implement it, I made a lot of mistakes based on kind of thinking the wrong way about it. First of all, it's not just more frequent performance tests, right? It's not just moving these big traditional performance tests earlier in the development cycle, and it's certainly not somehow faster or completely automated performance tests. But what it really is an appropriate level of evaluation of performance at each stage of the delivery cycle. It's more frequent, more visible feedback. An important aspect of that is trending that feedback across your build, so we can create really a continuum of performance data as we develop our applications. So let's take a quick step back. I'm saying that traditional performance testing doesn't work in Agile DevOps cycles, but there's certainly a lot of organizations that are developing software using a DevOps approach. So let's take a look at how they're doing. And if we look at this data from the 2019 State of DevOps report, not very well. Even the elite DevOps performers are only 28% of them have some form of automated performance test. So I think we could probably all agree that there's some room for improvement here. I think looking at that a little deeper, right? If even the top performers are lagging in terms of performance testing, there's probably something standing in their way. And I think in my experience, I've found a handful of things that stand in their way. First is a lack of performance-related requirements in the user stories, right? If we're not thinking about performance from the beginning, it's difficult and probably unfair to expect that our team to think about it as they begin to move through their delivery cycle. Similarly, development teams often lack the knowledge and the experience and expertise for performance testing analysis. And this is especially true in organizations where that was always someone else's responsibility, a center of excellence or some dedicated team for performance testing. Going along with that is the development teams not having accountability for performance in their daily work, right? Again, especially in those traditional situations where it was always someone else's problem. And finally, the concept of performance analysis was often limited to running these large-scale system-level performance tests, again, off in a separate team. And the organization as a whole really didn't possess the skills or tools required to analyze performance at a much lower level. So let's examine each of those obstacles and see what we might be able to do about it. Again, one of the huge holes I see in a lot of organizations is the failure to think about performance early. Again, created in older software development models where it was someone else's problem. But a good way to address this is to start thinking about performance factors. I'm talking about high-level attributes about performance as you go through your story. So let's take a look at this one where it's a story for a dealer of farm equipment to create quotes out in the field. If I think about performance factors, maybe I know that there's a peak of about 1,200 concurrent users, and that because they're literally going to be out in the field, we need this. We need to test this over varying network conditions. And I don't want screen-to-screen response time to be anything worse than 2 seconds. And at this stage, right, if we can think just at a very high level and jot these performance factors down as we go, we start to get this information out in the open. And I don't necessarily recommend spending a whole lot of time on this, right? Again, just trying to get it visible for the organization, so we don't leave it for a performance tester to worry about at the end. Thinking about those high-level factors, I think, is a good step, good first step. But we need to incorporate those requirements more formally in our work. And I've seen many ways that this can be done. I want to talk about some of the more popular approaches, but what really matters here is what fits with the way your organization works. What I often see here is to define those performance requirements as constraints. This is something that all or at least most of maybe your user stories, a group of user stories will have to comply with. So rather than including the same information in all the individual acceptance criteria, just link the appropriate stories acceptance criteria to these constraints. You, of course, also may have some performance requirements that are very specific to a story. In that case, we can include them directly in the acceptance criteria of the story. Again, how you do this is, I think, much less important than the fact that you're doing it, right? The key is to get awareness of the performance requirements. The method by which you do it is less important. I would start with what seems to work for your organization and expand what works, and of course move away from what doesn't. So, as I mentioned, another common obstacle is accountability. And it's not surprising that we see a lack of accountability, really. There's still a lot of inertia around that old traditional way of performance testing. And if we want to have accountability, in my opinion, we need awareness and visibility. If our teams aren't aware of what we're trying to accomplish, how can we hold them accountable, right? And again, as we just talked about, we get awareness by talking about performance factors and incorporating performance requirements early in our process. But we also need visibility. Awareness is one thing, but if we're not constantly reminded of how important performance is, we're probably going to let it slip into the background. And I found the best way to keep this visible is to ensure that our definition of done requires us to document those performance factors and acceptance criteria as part of our stories. I've even seen organizations create the role of performance owner, and this role isn't someone. It's not a role that does everything related to performance, but rather ensures that the organization is adopting a culture of performance and really provides some oversight and guidance to kind of clear the way for the team to execute performance testing activities and performance analysis activities that are appropriate for their role. And finally, integrate performance skills and tools into the delivery teams. We can't magically expect that our teams are going to have the knowledge and the tools to implement these performance-related processes, right? Especially if it was always someone else's responsibility. But we can start to seed the teams with those skills, especially if we've had a legacy performance testing team or center of excellence. We can start seeding those teams with resources that have that expertise. In parallel to that process, I think it's a great idea to develop what I call a virtual center of excellence that can provide the guidance and oversight for these performance-related activities. I'm certainly not talking about heavy process or oversight, but really just a virtual community that can work together to share ideas, lessons learned, and ensure that continued improvement and growth in this area. And what that helps you do then is to move from that centralized model where you have performance testing centralized in a separate team to start thinking about that and moving that to make it part of everyone's responsibility, of course, as appropriate. So how can we start to think about what we can do to create this continuum of performance data? I think a good way to think about that is to look at our pipelines and consider what we can learn about performance at each stage. So I've laid out a relatively simple pipeline here, but I think it will serve the purpose. So let's look at what we have. Certainly, we can learn about performance at the performance load stage, a dedicated environment to execute what looks more like a traditional performance test. Also, we can learn about performance at the integration stage. We're going to be upstream, and we're going to be focused on smaller test on very focused components. Certainly learn about performance in production. And of course, finally, yes, we can learn about something about performance at the commit stage. The key here is to evolve to a state of regularly evaluating performance, so it becomes easier to track performance regressions to the build or commit that they were introduced, right? The old traditional way of performance testing, when we did it at the end of a release cycle, makes it much more difficult, right? There's many possible culprits that are going to require investigation. So over the next few slides, I want to look at each of these stages in a little bit more detail. So let's start at the beginning of our pipeline and see what we can learn about performance at the commit stage. I'm talking about unit level performance testing. And yes, there's some organizations that are doing that. There are even some tools and libraries that are purpose built to help you do this. One of the more popular frameworks is JMH, but popular is a relative term here. There was a study out of Charles University in Prague, and I've listed the link there on the slide, that examined over 100,000 Java-based projects in GitHub, and they only found about 3% of them had any form of unit performance testing. So you really need to think about, hey, does this make sense for me to do at such a small level? But if so, there's certainly some resources out there for you. This isn't something that you're going to do for every method, certainly, but if you do it, they should be true unit tests, very independent, have their dependencies mocked. You're just, instead of a single functional test, you're executing using multiple threads over multiple iterations to get some data back. Certainly some important considerations to think about. You want to execute this if you can on every commit. Execute it on a dedicated machine if you can, because these measurements are going to be so small. Anything else going on in that environment can impact those results. And of course, you'll see a trend developing here, and that is these results should be trended across builds, right? And so you can start to develop that continuum of performance testing and see anomalies in that trend, and hopefully identify the cause as early as possible. So let's move down the pipeline. Definitely learn something about performance at the integration stage. This is after we've checked in our code, unit tests have passed, and we've moved our build to the integration environment. And these are tests focused on individual components, right? And these should probably be your most critical components at first. As when we talk about the approach, I'm going to recommend starting small. So it makes sense to start with your most critical components first. We're still early in our pipeline here, and we want fast feedback. So again, these are tests that are probably individual calls or a small series of calls executed by a small number of concurrent threads over a small number of iterations. We're not striving to execute a real life load at this point. We should also think about some considerations here as well, right? We're going to try to execute this on every deployment if we can. And these results probably aren't deterministic with a hard pass or a hard fail. So we're probably not automatically breaking the build with these tests, especially as you're just kind of learning to understand what the results mean. And of course, again, trend these results across build. The absolute values of the metrics are less important, right? We're not in a production-like environment. We're not executing production-like load, but we are trying to understand if we potentially have any issues, or just start to understand the performance characteristics in general of these individual components. So before we move on, I just want to spend a couple seconds to dive into this a little bit. We just talked about testing performance at a component level, but let's not kid ourselves, right? That may be easier said than done for many applications. For microservice-based architectures, that's fairly straightforward. The components are relatively focused, and we can design tests relatively easily around that. But for monolithic architectures, that concept of a component becomes a little bit fuzzy. It can still be done, But the way you need to think about that is to target areas of the application, whether it's in the business logic or even at the data layer, and then map user actions, small sets of user actions that target those specific areas. Again, it's easier said than done, and the amount of component level testing that you can do is probably going to be less on monolithic architectures for a couple reasons. Again, the concept of a component isn't as straightforward, but also the ability to create very targeted short tests that are easy to maintain is more difficult as well. So let's move on down to the acceptance stage. It's very common to have an inline environment where additional component tests can be run on single components or small subsets of components, but also an out-of-line environment where that more traditional level performance tests are run as necessary. For the inline environment, where you'll be running probably your automated functional regression tests, I also recommend capturing performance metrics, user-level metrics, browser-level metrics, as part of that effort, and those features can be added to a automation framework relatively easily by tapping into the browser performance APIs. Again, in this environment, we're going to have component level tests run on every deployment. Probably going to have our dependencies mocked to ensure that we can set the test up quickly and get fast feedback. For the out-of-line environment, again, more traditional performance tests. It's just that these become more a confirmation of what we already know, right? And the necessity to execute those tests and be the first indication of what the performance of our application is, we've taken that away, right? We already kind of know, based on our continuum of data, where we might have our problems. So before I move on to the end of the pipeline and talk about testing in production, I want to give you a bit of a conceptual overview of the process and how some tools might fit together. Of course, we have our system under test in our test environment. We've got some tools to generate our load on the system. Hopefully that we have some monitoring capabilities in these environments as well as necessary. Remember, we want to trend these results across builds. So we're going to want to save those results off, ideally in some type of time series database. And the organization needs to see them, right? We don't have a dedicated team anymore that goes and sits off in a vacuum and analyzes the results. We want to get the information as appropriate to the people that needs to see it. And of course, at some point, this should be as automated as possible. So let's dive a little bit more deeply in how we might approach doing this in our own shop. That picture I just showed you is a very mature implementation and not something that you're going to implement overnight. And it's not a trivial amount of work. So it's important that we approach it in the right way. If we went back and kind of locked ourselves in a room for 6 months to build something like that and then came out, it probably wouldn't be what the organization needs. So first thing I recommend is start slow and start small, right? Start with a single component, maybe even executed manually. Understand how that works. Understand the type of information that you're getting from that, and then as you become more comfortable, you can speed that up. You can add automation and start to scale that to other components and other delivery teams. This implementation of this type of process should be part of the technical backlog, right? So you can prioritize the work. If this is what I call off the books work or work that isn't formally tracked, it's likely never going to get done because we never, as a team, have that free time to implement this type of continuous improvement. Part of getting comfortable with the process is not overwhelming your team with information, right? This is information that the team likely has not received before, at least with any regularity. You need to prepare them So they are not only ready to consume it, but they understand it. And just importantly, the team needs to be prepared to act on it. Much of the value of performance testing is in the analysis. At least that's certainly been my experience. We can't assume that the team possesses the ability to understand the data you're giving them and take action on it. This is going to be a learning process. And also, the successful implementation of performance testing activities isn't just the implementation of tools. You need to make sure that there are supporting factors in place. We don't have unlimited time to execute tests, so we need to think very critically about which tests are important. If these tests are going to be executed as part of a delivery process, they likely need to be run on demand at some point. So we need to understand what that means from a test environment and a data perspective. And finally, this is not going to be a fire and forget solution, right? It's not going to be something you implement and it just works and you forget about it. As we implement continuous performance testing, you should be getting feedback from the delivery teams in terms of what information they're getting and what they understand and what they need to do with it. And as their ability to understand it and take action on it improves, they can provide you with valuable feedback on where to go next and how to continuously improve these activities. All right. So let's move on to talk about performance in production. I think most of us are probably monitoring our applications in production, at least we should be. However, testing in production, while certainly was not very well accepted, is fairly common today and an important part of continuous performance strategy. From a testing perspective, the obvious benefit is the confirmation that production can support your expected conditions, but it also allows us to test the entire system, not just what's behind the firewall. And with the wide availability of cloud-based performance test tools, we can evaluate the user experience from really anywhere we want to over varying network conditions. And when we combine testing with monitoring to give us specific data that we want by executing very specific synthetic transactions, that can be very powerful, right? We're not waiting to see what our users do to get that monitoring data, but we're executing synthetic transactions and getting exactly the data we want to be combined, of course, with our user-generated data. It's also important to have a continuous feedback loop between your monitoring strategy and testing in production. It's just going to allow for better test design and a better monitoring strategy. Of course, there's some things we need to think about if we're testing in production, because we need to, of course, maximize the benefits, but of course, reduce the risks as well. One mistake that I see, especially from the performance testing side, is creating that strategy in a vacuum, right? We need to get input from across the organization, so what we're doing in production is adding value to the organization. Certainly, if your app is hosted in a third-party environment, that this is something that's going to need to be coordinated with them. If the app is already live, you have customers, and we need to minimize the impact on those customers. So, depending on what you're doing, we can look for windows that minimize the impact, or maybe even cordon off part of the environment for the customers to use while you're testing on the remainder. And ideally, and I think this is important, the system should know it's being tested. After all, we're in production, and we can really screw things up depending on what we're doing. Whether it's using custom headers in your requests, seeding test data in production, or some other means, you need the system to understand that it's dealing with synthetic transactions. And again, this is another reason to have the broad input from across the organization. If the system is architected from the beginning, or at least adapted over time to be tested in production, this all becomes a lot easier. If we try to fit it in after the fact, we're just going to be limited a lot of times in what we can do. Finally, if the system uses third-party services, we probably want to mock them or eliminate them so we're not unintentionally impacting their customers. Finally, I just want to spend a quick minute on talking about testing, monitoring, and observability, and just the type of information we can get from this, so we can use it as part of our strategy. Testing, as we know, it confirms the answers to questions that we already know. We know what the answer should be. Testing confirms that that is in fact the case. Where monitoring gives us the ability to answer questions that we don't yet know the answer to, but we do know what questions we're going to ask. Observability carries that one step further and gives us the ability to get answers to questions we didn't even know we'd have to ask in the first place. So I've seen that using these three techniques in conjunction gives you a really broad view into the performance of your application, and just as importantly, the ability to dig into issues. So before we go to question and answers, I want to talk about a few key takeaways. First of all, traditional end of cycle performance testing just doesn't jive very well in short iterative delivery cycles. So as we just talked about, we need to develop this continuum of performance data. Don't make the mistake I did when I first started doing this and default to more faster performance tests and trying to shove them inside of the delivery sprints, right? There's a better way. And that better way is to proactively learn about performance at every stage of the delivery pipeline as appropriate, of course. And then finally, as we talked about the approach, start small, expand what works, and get feedback from the team, and as is important always in a DevOps culture, continuously improve. All right. Let's move on to any questions we might have.
All right. Thank you so much, Lee, for your interesting talk. So we have actually a few questions in the chat. So let's get straight to them. So the first one is by Wim. So he asked, and recent argument I often hear from customers moving to the cloud, why should I test performance when I have a full-scaled cloud? What is your opinion on that?
Yeah, I hear that as well very often. I mean, it's the full-scale cloud isn't magic, right? And assuming that you have your auto scaling set up correctly and configured correctly, even then, where are the bottlenecks, right? These systems don't just consist of a single tier of servers that magically expand, right? They're complex architectures and network topologies and other things. The bottleneck could be anywhere, and there's also the cost equation as well, right? As we know, the cloud costs are expensive, and just continuing to add servers and compute power and other resources is expensive. So by incorporating this performance testing activities into delivery cycle, you can first of all eliminate the bottlenecks that are going to be there independent of your scaled cloud, and second, minimize your costs associated with that.
Yeah, I find the cost part really relatable. I guess like every company needs to do that somehow. So all right, so we have another question. So have you come across performance testing of telecom functions? Have you managed to apply CI/CD for telecommunication companies?
So I have done some telecom testing. If you're talking about telephony systems, IVR systems, it's been a while. Used to do it relatively regularly using a tool suite called Hammer, which allows for functional automated testing and load testing of telephony systems. I have not done that in a while. Certainly not in the CI/CD. In a time where that was popular. It was more discrete, traditional load tests where we might be testing a call center and using Hammer to put load on to telephony side of the system, and then more traditional load tool to put load on the call center application. But sorry, no, I haven't done that in a CI/CD situation.
I guess maybe someone in the audience can answer this question as well. But yeah, I guess this helps. So we have another question from Andreas. Have you come across performance testing? No, we actually did this. At which stage would you start this improvement to maximize effect and/or ease of buy-in, like assuming nothing exists?
So typically we start at component level testing. So up front, maybe the first time the code is integrated, whatever environment that is in your organization. Why? Because it's especially if you've got a service-based architecture, it's relatively easy to identify the components. They're typically a series of API calls, service calls, relatively easy to script, relatively easy to test under small concurrent load, small number of iterations, and then just start to trend that data and identify additional critical components, expand from there. And once you kind of get that process down, you can start to expand to the other delivery teams. But that's typically the easiest place to start. It requires less setup and allows you to move forward and actually get some actionable data more quickly.
Yeah. All right. So we have one more last question right now. So interesting one. When you say start small, can you please provide a practical example of what you mean? So what is
Sure. So, there's really two aspects to starting small. One is the scope of the application that you focus on. Again, I'm talking about maybe a critical area of the application, some critical services that must be performant, right? Start there. And then I also mean just from a team perspective, okay? One of the mistakes that I made early on was trying to roll this out simultaneously across multiple delivery teams, and it just didn't work. There wasn't enough knowledge and experience to spread across all those delivery teams at once. So from a team perspective, what I mean is get one team stood up. They are the example. Figure out what works, what doesn't work in terms of who is responsible for creating the scripts, who's responsible for acting on the data, how is that data communicated. Work that out in a single team and then start to spread it out to other teams. And also, as you build the knowledge and experience in that first team, that you can start to use some of the resources from that team to seed the knowledge and experience in other teams as well.
Yeah, I guess that's right. So figuring out what works best and small, and then scaling it is always a good idea.
Yeah, I think this is true for many aspects of DevOps, but certainly for this, one thing I've learned is you can start out with an outline of a plan of what you want to do, but to try to figure out exactly what this is going to look like when you start is next to impossible. It's much better to have that culture of continuous improvement. If something doesn't work, get rid of it and move on to your next idea.
Yeah. All right, we have another question. So can you recommend any tools suitable for components performance testing with Python?
I don't usually use Python. I assume you're talking about creating the scripts in Python. I don't off the top of my head. Certainly from a executing API call perspective, we can do that in Python. The question is, can we create the scripts in Python and execute them in a multi-user kind of concurrent user traditional load test perspective? I don't off the top of my head know. But if there's a way for me to kind of track where this question came from, I'd be happy to do a little research and get back to you.
Yeah, maybe I don't know if it's fine for you. He can write you an email and then like.
Actually, that would be great. Yeah, my email address is right there on the screen. Send me a quick email, and I'd be happy to get back. And then if there's a way to post this to the chat somehow, I'd be happy to do that as well.
Sure, would be great. We can do that for sure. All right. So it seems like there are no more questions right now. So do you want to add something?
Just thank you, obviously, to the conference and to everyone that joined. Pleasure to be here. Wish I could have been there in person. I'm sure as we all did. But again, appreciate you coming out, and feel free to reach out to me through any of those methods. I'm always happy to talk about this stuff. And if I can't help, I probably know someone that can. So please don't hesitate to reach out.
All right. Thank you also so much, and thank you for listening to the talk. We will have like another session, so we will close this one right now, and then I guess we will see you soon in the next session.
All right. Thank you.
All right. Bye, everyone.